Hello and welcome to another British Tech Guru production. I'm your host, Zayford Beeblebronx. Over the last few days, maybe a bit longer, well actually a lot longer, I've been trying to get a solar tracker to work. And I've got all the bits, most of the bits. The biggest thing was I was trying to get this circuit to work. There you go. And that reads the light level using a photoresistor. And it works quite well. The only thing was I could never get it to work on the Raspberry Pi. So I jumped ship. It's working on the Arduino Metro, which is the Adafruit version. Slight change, there's actually 3 photocells there, if you can see it. 3 photocells, 3 resistors. And it wasn't working for me, and then I've finally got the leads the right way around. That helped a lot. And as you can see, as I said, very simple. 10k resistor, 3 of them, 3 photocells, and the rest is just wiring. Now you can buy modules to do that, but why buy when you can make it? Particularly when the bits are so dirt cheap. You can get them all on eBay. Well, I get all my electronics on eBay and AliExpress. Electronic components, that is. Now, I might be delving deeper into Arduino, but I don't know. I want to try that on Raspberry Pi in a bit. Right now, I'm really happy with it on the Metro. The next thing will be to install a couple of H-bridges to drive electric motors so that I can aim the solar light sensors at the sun, so they're always optimally aimed at the sun, with the aim of using the sun to focus light through a magnifying glass on a coin, with the thought I might try to melt the coin, or at least do something with it. That might need a big magnifying glass. I'll just try it. It sounds like a fun thing to do. But the big thing is, at the end of all this solar tracker circuit, and notice I've used 3 light sensors. Well, the aim of that is to work with the Pi Pico, which is the ultimate aim anyway. And I want it to track the sun in this instance. I will move on from there to audio tracking, because I want to be able to track sounds in 3 dimensions. I'll probably use 4 microphones for that, so that really rules out the Pi Pico or any Raspberry Pi, unless I use an analog digital converter with multiple channels and an I2C interface. But even then, the Pi will be ruled out, because I want to calculate the speed of the sound, the distance the sound takes. So put that another way, I want to time sound as it travels over about 2 inches of space between 2 microphones, which should take a fraction of a second, and that I can use to give not just direction of the sound, but the distance of the sound too. And then, and this is all geometry, you did it in school, you've probably forgotten about it. Anyway, get the sound calculated for distance, and then using some kind of tracker, probably a magnetic tracker, I can track degrees of movement as the microphone follows the sound. Then using the speed of the sound, I can calculate the distance to the object and then predict how far ahead of the object I need to aim to hit it with a laser. And that's all I'm trying to do. Hit a moving object using sound waves with a laser. And this is the very start of that project. This is just going to get the tracking working so that I can track the sun, but then I'll work on tracking sound, and then later, further on there, predicting the origin of the sound and hitting it with a laser beam. A lot of applications for that. And this has been another British Tech Guru production, and I'm your host, Beeblebrox.